Okay, I'm going to go over the study guide with you guys. If you are in my class, then you use this to correct the study guide for fall semester. If you're not in my class for Math 7, then you can just see how to do the basic skills the first semester of Math 7 if you want to. Basically, the first section is conversion practice. So what I'm going to do here is I'm going to show you how to convert from a fraction to a decimal to a percent and vice versa. So basically, just going to find the missing value. It says you're starting with 1/4, and that's equivalent to 25%. And they're asking you what's the decimal version of that. So the nice thing is once you're given this percentage, right, uh, it's really easy to convert a percentage to a decimal. All you got to do is drop the percent sign and move the decimal place wherever it is 2 to the left. Because basically this is 25 over 100. And so you're dividing by 100. So when you divide by 100, you're moving 2 to the left. So the answer would just be take that, move it 2 to the left, and you're going to get your answer as 0.25. And that makes sense because this is 25 ending in the hundredths place. And that's what 25% is, right? 25 per 100. And that's also the same as 1/4 because remember, to create an equivalent ratio to 1/4, you would just multiply top and bottom by the same amount. If you multiply top and bottom by 25, you get 25 over 100, hence 25 hundredths. So the answer for 25% is 0.25. And that's how you do it. Okay? Let me see if I can turn this off. All right, let's see if that's better. So over here, we have question mark is equal to 66.6 repeating percent is equal to 0.6 repeating. So this is a little trickier because it's got that repeating element to it, but we want to write it as a fraction. We have the decimal, we have the percent, we don't have the fraction. We'll go back to the focus. I think it works a little better. And so what we're going to do here is we're going to hopefully remember some things. The first thing to remember is when you have a repeating element like this that's ending in the tenths place, then the way you can convert that to a fraction is you're just going to write it not in the tenths place, but in one less than the tenths place. So if the repeating element ends in the tenths place, it's going to be over 9. Okay, so this is the same as 6, the repeating element, over 9. And that would be 0.6 repeating. And we can simplify 6/9 as 2/3 because we can divide top and bottom by 3. 6 divided by 3 is 2. And then, of course, 9 divided by 3 is 3. So the correct answer here would be 2/3. All right, that's the missing value. And you might want to double check that. So you can always do division to check that. 2 divided by 3, is that in fact equal to 0.6 repeating? So we do a little math here. Bring your decimal up, add a 0. 3 goes into 2 0 times. 3 goes into 20 6 times. That's 18. There's 2 left over. 3 goes into 20. Guess what? 6 times. It repeats. Hence 0.6 repeating. So yeah, we know it works. That is the correct answer. Awesome. And then for the next one, we've got 7/8 is equal to some percent we don't know, is equal to 0.875. Now, the nice thing is you're given the decimal, you're given the fraction. The only thing that's missing is the percent. When you are given the decimal, it's kind of the opposite over here when you're given the percent. Here, you drop the percent sign and move it 2 to the left, right? Because you're going to go to the decimal. Remember, decimal has an L in it, so you move to the left. But when over here with the 0.875, you're given the decimal, but you don't have the percent. Percent has an R in it, so you're going to move it 2 to the right. Basically, what you're doing is you're saying that this is the same as 87.5 over 100, right? Because that's what a percent is, over 100. So it's 87.5%, okay? And mathematically, this is what's happening. 0.875 all over 1 is equivalent to 87.5 all over 100 because you're going to multiply the top and bottom by 100, right? Remember the giant 1? Whenever you multiply the top and bottom by the same amount, you multiply by a version of 1, which creates an equivalent ratio. So 0.875 times 100 is 87.5, and then 1 times 100 is 100. Hence, you have created an equivalent value. It didn't change it, but rewrote it as a percent, right, out of 100. So that is the correct answer. So that's what you guys should have for those three answers. Number 1 should be 0.25. Number 2 should be 2/3 in simplest form. And number 3 should be 87.5%. All right, let's continue. Here it says operation with rational numbers. So now we're going to go through and just, remember our basics. So when you're multiplying a positive times a negative, you guys remember when the sign's different, the answer is going to be negative. So positive times negative is going to be a negative. Always reserve your sign first. And then what's 8 times 10? It's 80. So this is going to be negative 80. Remember the rule for multiplying and dividing. So some people say it's the mod face like this. And you've got like the little face where mod's sleepy, not dead. So that's like negative times a negative is positive. And then in this case, positive times a negative is a negative. Or alternatively, you can just say that if the sign's the same on the two factors, it's going to be positive. If the sign's different on the two factors, it's going to be negative, right? So if you're looking at a positive times a positive, that's a positive. If you're looking at a negative times a negative, it's also a positive. Since the sign's the same, the answer is positive. If you have a positive times a negative, it's going to be a negative. And if you have a negative times a positive, it's going to be a negative, right? The signs are different, the answer is negative. So if that helps you, great. So in this case, this is for multiplying and dividing. It doesn't work for addition and subtraction, but it does work for multiplying and dividing. So a negative 15 divided by a negative 3, a negative divided by a negative is a positive, and then 15 divided by 3 is just 5. So this is just positive 5. I boxed my answers just to make sure that they're not confusing or anything. And then negative 4 times a negative 12, a negative times a negative is a positive, and 4 times 12 is 48. And that's how you do that. This one over here is going to be number 7, 1/2 take away the quantity of negative 2/5. You can rewrite the subtraction as additions. This would be 1/2 plus the opposite of negative 2/5, which is positive 2/5. Then you need to have a common denominator. Sorry, I'm back. My daughter needed something. All right, so where was I? Oh yeah, 1/2 plus 2/5. So in this case, you're going to change to a common denominator. You got to make these the same size pieces before you add or subtract. So both 2 and 5 can become 10. So you're going to rewrite these as tenths. So it'd be tenths plus tenths, right? And then when we create equivalent ratios out of 10, you're just going to multiply top and bottom by the same value. So what would you multiply 2 by to get 10? 5. So 1 times 5 is 5. What would you multiply 5 by to get 10? 2. So then 2 times 2 is 4. So this is the same as 5 tenths plus 4 tenths. And that means you have how many tenths, right? The size of the pieces is tenths. The top is how many pieces you have. So you have the same size pieces, tenths, but how many do you have now? You have 9. So the correct answer in this case is just positive 9 tenths. And the trick to doing this problem carefully is to remember that when you want to change subtraction to addition, you got to change what was being subtracted to its opposite. So taking away a negative 2/5 is exactly the same as adding a positive 2/5. Over here, you've got negative 1/3 minus 1/9. This is the same as negative 1/3 plus the opposite of 1/9, which is negative 1/9. Now we got to make our common denominator again. So this is the same as negative 1, how many ninths, I should say. So we're going to make it out of 9, since both 3 and 9 can become 9. So 1 times 3 is 3, 3 times 3 is 9. So we multiply top and bottom by 3, we're going to get 3 ninths. And then you're adding to that negative 1/9. So how many ninths do you have in all? That means that you have a total of negative 4 ninths. Remember, when the signs are the same and you're adding them together, you keep the sign the same and you add them up. Okay, so this is negative 4 ninths. So I'm going to put that up here, negative 4 ninths, and box it. And now you can see my work and you can see my answer. Over here, we've got negative 18.5, take away negative 6.04. Once again, rewrite your subtraction as addition. So this is the same as negative 18.5 plus the opposite of negative 6.04, which is positive 6.04. And so now this is the situation we're really looking at. You ask yourself, okay, are they going the same direction or different directions? Remember, if they go the same direction, you keep the sign the same and add them together. In this case, these two integers or these two decimals are going in different directions, right? So you got to figure out who's going to win and by how much. So the negative is more powerful, right? It's pulling further from 0, so it's going to win. By how much? So I know the answer is going to be negative, and we got to find the difference here. So this is going to be 18.5, and we're taking away from that 6.04. Now you got to make sure you line up your decimal and put your placeholders in. It's very important whenever working decimals to line up your decimal. And then you can do your math here. So 0 take away 4, you can't do it. You borrow. 10 take away 4 is 6. 4 take away 0 is 4. 8 take away 6 is 2. And then 1 take away nothing is 1. So the answer is going to be 12.46. So it's going to be negative 12.46. Put your decimal in carefully, and you're good to go. Okay? Okay, the next skill we're going to practice is multiplying fractions. So when you are multiplying fractions, a couple things to keep in mind. You don't need a common denominator, okay? You're just going to multiply across the top and bottom and then simplify. If you are trying to make it easier for yourself, then across the multiplication symbol, you can cancel one from top, one from bottom. So let's practice that skill. Let's see if there's anything to cancel. I like to call it dancing, but basically it just means dividing top and bottom by the same amount, okay? So in this case, you have 3/4 times the quantity of negative 16/21. The first thing you should always do is resolve your sign. When we talked about it, what is a positive times a negative? Positive times a negative is going to be negative. So put a negative in a box, you know the answer is going to be negative. All right? And then let's just do it without the sign. 3/4 times 16/21. what I would ask is, are there any common factors in the top and bottom? And I think there are. You guys can see that. You've got 3 on top and a 21 on bottom. Both of those are multiples of 3. So you can divide the 3 by 3 and get 1. You can divide the 21 by that same 3 and get 7. So you basically divided top and bottom by 3. That's 3 over 3. When divided by 1, it doesn't change anything. So that's going to keep everything the same. But it's going to make things simpler for us. All right. And then over here, you got 4 on bottom and 16 on top. Both of those are multiples of 4. Remember, as long as it's 1 on top, 1 on bottom, you can cancel them out by the same factor. So 4 divided by 4 is 1, and 16 divided by 4 is 4. So now, once you've simplified it by dividing top and bottom by the same values, pulled out all those common factors, call it cross-canceling or dancing, then you can multiply across the top and across the bottom. And what you get is 1 times 4, which is 4, all over 1 times 7, which is 7. So the correct answer here is 4 over 7. So we know it's not positive, though. It's going to be what? Negative. So it's going to be negative 4/7. And that is your correct answer. That's why it's really important to put the sign in the box before you start, so you don't lose your sign. Because sometimes we get a little busy doing other things. We forget where our sign is. Okay, so that's very good. All right, so this one is division. So this is how you divide fractions. So the same principle for a sign is that this is positive divided by negative. So we know the answer is going to be negative. So put a negative in a box, resolve your sign first. And then you're going to do 7/8 divided by 21 over 56. So 7 over 8 divided by 21 over 56. You cannot cross-cancel or dance across division. You have to only dance or cross-cancel across multiplication. So in this case, what you're going to do is you're going to first change your division into multiplication. Sometimes we say dividing fractions is easy as pie, just flip the second and multiply. Sometimes people say keep, flip, change. In other words, keep the one on the left the same, flip the one on the right to flip the operation to its inverse operation, and change the one on the right to its reciprocal. So you can do that. 7/8 stays 7/8, but the division changes to its inverse operation, multiplication, and the one on the right, the one that you're dividing by, flips top to bottom to its reciprocal. So this would be 56 over 21. Okay, now we have an equivalent multiplication problem that's easier to solve, because now you can dance, you can cross cancel. So in this case, when we cancel, we're going to get 7 cancels with 21. So both of those can be divided by 7. 7 divided by 7 is 1, and 21 divided by 7 is 3. And then 8 and 56 are both multiples of 8. 8 divided by 8 is 1, and 56 divided by 8 is going to be 7. Once you're done canceling, multiply across the top, multiply across the bottom, and you're going to get 7/3. Now, how many times does 3 go into 7? Twice. With how many left over? 1. Because 2 times 3 is 6, so there's 1 extra left over. So the correct answer is -2 and 1/3. And that is what you guys should have. If you have that, good job. You did a great job on your problem. All right, last but not least, we're going to do a little dividing decimals. So the first step is to decide what your sign is going to be. Remember, we talked about it. A negative divided by negative is a positive. So put a positive in a box. You know the answer is going to be positive. And then the first value goes inside. So 0.822 goes inside. And the second value goes outside, which is going to be 0.3. Notice that I ignored the sign once I knew the sign was positive on the answer. And now we ask ourselves, are we dividing by a fraction, dividing by a decimal, or dividing by a whole value? If you're dividing by a whole value, you just bring the decimal up. If you're dividing by a decimal, you got to make it a whole value first. So move it 1 to the right on the outside, move it 1 to the right on the inside, then bring it up. The reason that you're doing that is basically you're looking at a situation that's a ratio of 0.822 all over 0.3, and you're multiplying top and bottom by 10, so that it's an equivalent ratio 8.22. Let me change that. 8.22 all over 3. And that's basically what happens here, right? So instead of the decimal being here, let's move it to here because we're dividing by 3, not 0.3. And that just makes it a little easier because it's easier to think about how many 3's go to something than how many 0.3's go to something. So 3 goes into 8 how many times? That would be 2. That's going to be 6. There's 2 left over. And then bring down. 3 goes into 22 7 times. That's 21 with 1 left over. And then bring down. And then 3 goes into 12 how many times? 4. And 3 times 4 is 12. There's nothing left over. So you are done. Okay, so the correct answer is positive 2.74. And that's what your answer should be. And that's the work you should have. Okay. All right, let's go down. The next one's the order of operations problems. So the way I like to do order of operations, I like to kind of circle my terms. Now, for you guys, I'm going to box my terms, all right? So remember, terms are the things that are separated by addition or subtraction outside of parentheses. So I'm going to start by just kind of setting that up and boxing my terms, right? So in this case, I see that I've got 126 as a value. That's its own value. And I've got basically take away 9 divided by 2. 9 divided by 2 is its own value. The separator is the subtraction sign there, right? So it's really 126, take away the value of 9 divided by 2. So once you've done that, you can use PEMDAS. So in that structure, we're going to do PEMDAS. The 126 just stays 126. The takeaway operation just stays takeaway. But what is 9 divided by 2? 9 divided by 2 is going to be 4 halves, 4.5, I should say, or 4 and 1/2, 4.5. So really, this is going to be 126 take away 4.5. Now that I've got it as just one operation, I can just combine left to right the value of the terms. So what's 126 take away 4.5? The value is going to be 126 take away 4, which is 122, and then take away 0.5. So it's going to be 121.5. Now, if you guys want to do it the long way, you draw it like this. You do 126.0, and you're taking away from that 4.5. Make sure you line up your decimals. You close that. All right, I'm going to line up your decimals here. There we go. So it'll be 4.5. And when we do that, you're going to say 0 take away 5 is something we can't do. You're going to borrow here, so let's do it in purple. You're going to borrow from the 6, make it a 5. This becomes 10. 10 take away 5 is 5. And then 5 take away 4 is 1. And then 12 comes down, basically, right? Or 121. So you get 121.5. All right, same answer. So this is going to be a positive 121.5. Box your answer. That is what it is. Verified it. All right, this one over here, we're going to once again separate our terms. Our terms are going to be the things that are separated by the addition, subtraction outside of parentheses. So I'm going to circle our terms. This first term that I see here is going to be the value of 125 divided by 5 squared. That subtraction outside of parentheses is a separator. And then I see the next one, which is going to be the value of 18 divided by 2. So this is really two terms that are being combined by a subtraction sign. And then let's find out what those values are. Within each of those terms, you're going to use PEMDAS to figure out the value. So here we've got division and exponents. You're going to do the exponents first. What is 5 to the second power? It's 5 times 5, which is 25. So this is 125 divided by 25. Keep working within that term. So what is 125 divided by 25? Well, how many 25s go into 125? That would be 5. 5 times 25 is 125, right? 5 quarters is $1.25. And so then we can see that that's the value of that first term. And then the operation stays the same, subtraction. And then over here, you've got 18 divided by 2. What is 18 divided by 2? Just 9. So this is really 5 take away 9. And as you guys know, 5 take away 9 is exactly the same as 5 plus negative 9, right? Taking away a positive 9 is the same as adding a negative 9. So who's going to win, positive or negative? The negative by how much? 4. So the answer there is negative 4. And that's what you guys should have. For this one here, we're going to circle our terms or identify our terms. We've got 2 take away 1 in parentheses. That's one quantity. And then you're adding to that the quantity of, let me do that over here, 8 minus 2 to the second power. Okay, so they're separated by addition outside of parentheses. Remember, the separators are always subtraction or addition outside of parentheses. Then work within each of these terms to find its value. And then we can combine left to right or in any way you see fit because you're just basically combining with adding and subtracting, which happens at the same time. So what we're looking at here is you've got 2 take away 1, which is 1. And then the operation between them is addition. And then over here, you've got 8 minus 2, which is going to happen first because inside the parentheses. 8 minus 2 is 6. So it's a 6 to the second power. We're going to keep working on this one because there's more to do. And then 6 to the second power means 6 times itself, which is 6 times 6, which is 36. So it means you're going to have the answer of 1 and then plus 36. And 1 plus 36 is, of course, as you guys know, 37. So the correct answer here is going to be positive 37. And that is the answer to that order of operations problem. All right, so next we're going to talk about probability. Remember, probability, theoretical probability anyways, is pretty simple. It's just favorable outcomes over possible outcomes. It's a chance of something occurring. And then experimentals, the same thing, except it's the desired number of trials, like the trials you're looking for, over the total number of trials, right? And experimental probability just means that you're working off of data that's been previously collected. And theoretical probability is just looking at a model and figuring out what's going to happen based off the model. And so in this particular case, I think these are mostly theoretical probability problems. So it says the chance of rolling, that should say the chance of rolling, but it says the chance or rolling. That's just a typo. So the chance of rolling an even number greater than 4 on a standard 6-sided dice. So the first thing you want to do is list out the sample space. So the sample space is just the collection of all possible outcomes. So in this case, the sample space is going to be 1, 2, 3, 4, 5, or 6, right? These are all the things that could occur. And we want to ask ourselves, what are the favorable things, right? So the favorable things are going to be even numbers that are greater than 4. Okay, so obviously even numbers would be things like 2, 4, and 6. We want the ones that are greater than 4. Well, 4 is not greater than 4. 4 is equal to 4. And 2 obviously is not greater than 4. So the only one of those that works is 6. That's the only favorable outcome, right? So that is your favorable, right? So we circled your favorable outcomes. Those are the favorable outcomes, just the 6. So when we talk about the probability of this occurring, it's going to be the number of favorable over the number of possible. How many favorable outcomes are there? 1. How many possible outcomes are there? 6. So the answer is 1/6. There's a 1/6 chance that you're going to get an even number greater than 4 when rolling a 6-sided number cube. Okay. This one says the chance of not drawing a red card from a standard deck of cards. Well, when you think about a standard deck of cards, it has 4 suits, 2 of which are red, 2 of which are black. Right? There's hearts and diamonds, and there's spades and clubs, right? So that means that basically half the deck is going to be red, and half the deck is going to be black, right? So if you're thinking about it, right, I think we can safely say that basically there's 2 options in the deck that are equally weighted. There's red and there's black, right? So this is like our sample space. There's the red cards and the black cards. And it says the chance of not drawing a red card. Okay, so we don't want a red card. Well, the only other cards are black, right? So basically that means that the black are the favorable outcomes in this case, right? They're the not red cards. And so we can see that the favorable outcomes will be 1 out of the total possibilities, which is 2. So it's 1/2, right? Half of the time you're going to get either red or black, basically. So that's kind of how that works, right? Remember the concept here of not drawing a red is basically saying that together, not drawing a red and whatever and red have to be complementary out to 100% because all the possibilities, right? So not drawing a red is basically black, right? And as you can see, red plus black would be the whole thing, or 2 out of 2, or 100%. So in this case, though, it's really easy. It's just half, right? Because half the deck's red, half the deck's black. So that's it. Now, just because this is the theoretical probability doesn't mean that every single time you draw from the deck twice, you're going to get one red card, right? There's luck and chance involved with any particular experiment or trial. But it just means that in theory, you should get the red cards half the time, and you should get the not red cards half the time. And so basically that means if you were to conduct an infinite number of trials, right, it would approach that value of 50%. Over here it says you are drawing from a bag containing 3 red, 4 green, 17 blue, 26 black marbles. What is the chance that you, on a single draw, you get a red? So this, once again, we want to list out our sample space. So here's our sample space, the collection of all possible outcomes. In this case, it's just the bag, right? What's in the bag? So in the bag, you've got these 3 red marbles. You've got the 4 green marbles. You've got the 26 black marbles. And you've got 17 blue marbles, okay? Now, you want to ask yourself how many total marbles are in the bag, because in order to do theoretical probability, you have to have favorable over possible, and possible means like total possibilities. So in this case, you've got 3 plus 17 is 20, and then this is 30, so about 50, right? So we want to count that really carefully, and it adds up to 50, right? So I know that 3 and 17 is 20, and I know that 4 and 26 is 30, and 20 and 30 is 50. If you wanted to just add it traditionally, you could say 3 plus 4 is 7, plus 6 is 13, plus 7 is 20, put the 0, carry the 2, and then 2 plus 2 plus 1 is going to be 5. So it would work either way. But ultimately what you got is you got a total of 50. Double check the total because you have to make sure that's correct. So we know that our favorable over possible is going to be out of 50, right? Okay, cool. And then it says what it wants is, what's the chance of getting a red? All right, so how many reds are there? There are 3. So that means that our favorable are just the reds, right? These are the things that are favorable that we want. There's 3 of those out of how many? 50. So the fraction or the ratio is 3/50. Now, that can't be simplified, so that is the correct answer in simplest form. So that's what you put into your answer document, 3/50. Okay? And that's how it works.